In the final section of today's lecture, we will see how alkoxides act as nucleophiles. We have already seen a lot of these reactions, and this is really just a review. But basically, alcohols can be converted into alkoxides by the use of base, and this means sodium amide or butyl lithium or sodium hydride, to give us alkoxide, in this case sodium or it could be lithium, plus in the first case it will be ammonia, in the others it will be butane or hydrogen. And that will be an acid-base reaction that gives us an alkoxide. Alkoxide can also be obtained through formal redox reaction by simply reacting alcohol with sodium, and this will release hydrogen as a gas and provide us with alkoxide. Now, once the protonated alcohols in the form of alkoxide are strong both as nucleophiles as as bases, and so if we have this ethoxide reacting in a formal SN2 reaction, it will easily expel this to give us this butyl ethyl ether, and this is known as Williamson ether synthesis. This reaction, unlike the acid catalyzed synthesis of ethers, works for unsymmetric systems too, and this is one of the methods of choice for preparation of ethers. However, it is severely limited by the steric bulk in the alkoxide. So if we have a T-butoxide and this very same substrate, instead of getting the SN2 reaction, we will get an E2 reaction where the alkoxide, instead attacks this hydrogen, establishes a double bond and bromine leaves to give us ultimately protonated alcohol, alkene, and Br-. Okay. And so alkoxides can be useful both as nucleophiles and as bases, but they rarely achieve both functions at the same time. This will be the end of today's lecture, and this will also be the final lecture where we talked about reactivity of classes of organic compounds. So we've seen quite a long way from alkanes, which are quite unreactive compounds, to alkyl halides, where we've seen substitution elimination reactions, to alkenes, where we introduced the addition reactions as a new general class of reactions, and we've seen that these addition reactions are pretty general, that they work on other pi systems such as alkynes. And then finally ended with alcohols, which show a little bit of everything. They can be both nucleophiles and electrophiles, and show quite diverse reactivity. In the next lecture, and then the following couple of lectures, which will also finish our course for this semester, we will see something completely different, but still very important. We'll see how we're able to prove the identity of compounds that we make through all of these reactions using spectroscopic and spectrometric methods. With this, we'll finish today, and we'll continue next time. Thank you.